Yes,
Please insert the F5. F5 at the top of your keyboard. You can see over there the F5 key. Press it. Press it. F5. F5,
دكتور
my friend.
اوكي.
So
استاذ
far,
احمد استاذ احمد دوس F5 من الكيبورد F5 من الكيبورد
yes, yes, دكتور, yes.
F5.
استاذ حسام يمين
To show the full screen of your presentation. Yeah, that's very good. Thank you very much.
Yes, دكتور, yes.
Thank you very much. Go on, please.
Yeah.
Go on.
Introduction. Connection from an important part of any structure and are designed more conservatively than members. This is because connections are more complex than members. To analysis and the discrepancy between analysis and actual behavior is large. Further, in case of overloading with warfare, the filer confined to individual member rather than in connection which could affect many members. Connection account for than help the cost of structure, steelwork, and so their design and detailing are of primary importance for the economy of structure. Classification of connection. Method of fasten, rivet, bolt, and welding. Connection rigidity, simple, rigid or semi-rigid joint, resistance, pairing connection, and friction connection. Fabrication location, shop or field connection. Joint location, beam column, beam to beam, column to foundation. Classification. Classification of connection. Connection geometry, single wave angle, single blade, double wave angle, top and set angles, with and without stiffness and blades or header blades. Welded connection using blade and angle tape of force transfer across the structure. Connection shear, connection or simply moment. Connection tension or compression with shear. Classification based on joint rigidity. They develop the full moment capacity of connecting members and retain the original angle between the members under any joint rotation. Rotational movement of the joint will be very small. Simple. No moment transfer is assumed between the connected parts and hence assumed as hinge bend. Rotational movement of the joint will be large. Semi-rigid may not have sufficient rigidity to hold the original angle between the members and develop less than the full moment capacity of the connected member. In reality, all the connection will be semi-rigid. Example of rigid connection. The figure is shown. Example of bend connection. Bolted bend connection, welded bend connection. Why connection failure should be avoided? A connection failure may be lead to a catastrophic failure of the whole structure. Normally, connection failure is not as ductile as that of a steel member failure. For achieving an economical design, it is important that contractors develop full or a little extra strength of the members. It is joined. Connection failure may be avoided by adopting a higher safety factor for the joint than the members. Rivet and riveted connection. Riveting not used now due to the necessity of permitting the rivet prior to driving. Labor cost associated with a large riveting group. Cost involved in careful inspection and removal of poorly installed rivets. High level of noise associated with driving rivets. Type of bolts: efficient bolt or black bolt or C. A grade bolt IS 1363-1992. Bearing tape connection. Tyrant bolt, expensive and used in SPI jobs. Precision A grade and semi-precision B grade bolts IS 1364-1992. They are used when the no slippage is permitted. Rivet bolt. Rarely used in ordinary steel structure. High strength bolt IS 3757-1985 and IS 4000-1992 friction tape connection. A black or ordinary bolt and nut. Shown figure below. Rectangular head black. Bolt and nut IS 1363. Figure and brackets are for high strength bolt and nuts. Net. Black bolts are installed in clearance holes of about 1.5 millimeter to 2 millimeter more than the bolt diameter and then tightened through the nets. Tensile properties of fasteners. The figure shown tensile properties of fasteners. In proprietary class 4.6 number 4 indicate 1 per 100 the nominal ultimate tensile strength in Newton per millimeter square, and the number 6 indicates the ratio of yield stress to ultimate stress expressed as a percentage. The ultimate tensile strength of a class 4.6 bolt as 400 Newton per millimeter square, and yield strength is 0.6 times 400, which is 214 in Newton per millimeter square. Dimension of grade 4.6 hexagon head bolt IS 1364. The figure is shown below. Size in the bracket not perfect. Dr. hear me?
Go on, please. We are hearing you.
Yes.
We are hearing you. Don't worry about it.
Yes. High strength bolt 1 IS 3757. The figure is shown. Made from parts of medium carbon steel bolts of proprietary class 8.8 and 10.9 are commonly used. High strength bolt. The material of the bolt do not have a well-defined yield point. Instead of using yield stress, a so-called proof load is used. The proof load is the load obtained by multiplying the tensile strength area, approximately equal to 0.8 times the shank area of bolt by the proof stress in IS 800. The proof stress is taken as 0.7 times the ultimate tensile stress of the bolt. High strength bolt. The figure is shown. They are identified by manufacturer's identification symbol and proprietary class identification symbol 8S or 8.8S or 10S or 10.9S, which will be embossed on the head of this bolt. A class 10.9 bolt should not be hot dab galvanized. High strength friction, HSVG. Special techniques are used for tightening the net to induce a specified inertial tension on the bolt called the proof load, which causes sufficient friction between the firing faces. Such bolts are called high strength friction grip bolts, HSVG. Due to this friction, the slab in the joint is elemented joint with HSVG bolt are called now slab connection or friction tape connection. Bolt tightening techniques when slab resistance connection are not required. High strength bolt are tightened to sunk tight using an ordinary speed wrench. When slab resistance connection are desired with HDFC bolt, three methods are used. Turning of the net tension part turning method, cheap, more reliable and common method. Direct tension indicator tightening, calibrated wrench tightening, torque control method. Bolt tightening using impact wrench. The figure is shown. Turning of the nut tightening in the American practice 1/3 turn of the net is prescribed for a bolt length less than 4D 1/2 turn of the net for bolt length from 4 to 8D or 200 millimeter and 2/3 turn of the net for bolt length greater than 8D or 200 millimeter, where D is the diameter of bolt. Solomon and Johnson 1996. The bolts are tensioned using 1/8 turn increments. Behavior of bolt turn of the net method. The figure is shown. Direct tension indicator tightening. There are two types of proprietary load indication device. The first type of device indicate the load by producing a measurable change in gap between the net and the grabbed material. Direct tension indicator tightening. In the second tape, the bolt is tightened by turning a net which has a production knob. The tightening is connected till the knob shear off. Calibrated wrench tightening. Wrenches are calibrated by tightening in hydraulic tension measure device using a minimum of 3 bolts of the semi-diameter. Impact wrenches are set to still when the perceived by tension and is reached a click. Sound can be heard and felt when the set torque is reached. Manual torque wrenches have a torque indicating device using which the torque required to produce the initial tension is measured. Advantage of bolted connection. Bolted connection offer the following advantage over riveted or welded connection. Use the unskilled rubber and simple tools, analysis and quick fabrication. No special equipment process needed for installation. Fast progress of work. Accommodate minor discrepancies in dimension. The connection support load as shown as the bolt are tightening and welding and the rivets, cooling period involved. Main drawback of black bolt is the slab of the joint when subjected to loading. Load deformation behavior of different type of fasteners. The figure is shown. Advantage of SVG bolt. HSVG bolt do not allow any slab between the element connected, especially in the closed torus holes. Thus, they provide rigid connection. Because of the clamping action, load is transmitted by friction only, and the bolts are not subjected to shear and bearing. Due to this similar number of bolts, the cused blade size are reduced. Deformation is minimized. Holes larger than usual can be provided to assist irrigation and take care of lack of width. However, note that the type of hole will govern the strength of the connection. Now less fabrication since and the bolts are tinted with wrenches. Advantage of HSVG bolt. The possibility of failure at the knit section under the working loads is limited, since the load causing fatigue will be within proof load. The net are prevented from losing, and the fatigue strength of the joint will be greater than in welding dead connection. Since the load is transferred by friction where there is no stress connection in the hole. Unlike riveted joint, few persons are required for making the connection. No heating is required and no danger of tossing of the bolt. The safety of the workers is enhanced. Alteration, if any, replacement of defective bolt is done easily than in welded connection. Drawback of HDPC bolt. Bolting usually involves a significant fabrication effort to produce the bolt holes and associated blade or clates. Special procedures are required to ensure that the clamping action required for preloaded friction grip joint are achieved. The connection with HSVG bolt may not be as rigid as a welded connection. HSVG bolts are about 15% higher than black bolts. Bolt holes. Bolt holes are usually derived IS 800, always punched hole only in material whose yield stress Fy does not exceed 360 megapascal and where thickness does not exceed 5600 per Fy millimeter. Bolt hole are made large. The bolt diameter to factories erection oversized hole should not exceed 1.25 D or D plus 8 millimeter in diameter, where D is the nominal bolt diameter in millimeter. Slotted hole provided to accommodate movement should not exceed 1.33 D in length for short slotted hole and 2.5 D in length for long slotted hole. Pitch, stagger, hole, and gauge. The figure is shown. A minimum space of 2.5 times the nominal diameter of the fastener is specified in the good to answer that 3 is sufficient space to tighten the bolt to prevent overlapping of the washers and to provide adequate resistance to the tear out of the bolts. Bolt diameter, pitch, and each distance as per IS 800. The figure is shown. Gauge distance for bolts as per SB1. The figure is shown. Not on IS rolled section. Yes, Doctor?
I said, please summarize your presentation. We don't have much
Yes,
time to
Doctor.
present another present.
Yes, Doctor. Yes. Similarly, different type of bolted connection were described and classified. The bearing and friction grab bolt were introduced, and their insulation procedure described. The force transfer mechanisms were explained, and the filer modes and cross bonding strength calculation were given. This will help in the design of simple bolted connection as in the worked example. Thank you, Doctor. Doctor, you hear me?
Ahmed Abbas, thank you for your presentation. That's very good presentation.
Thank you very much, Doctor. Thank you very much.
Your score is 93. Thank you very much. That's a very good.
Thank you, Doctor.
I give that.
Welcome.
Ali Ahmed Ali, are you ready?
Hello, Doctor. How are you doing?
Good, thank you. And is everything okay? And are you ready to present?
I'm ready. I'm gonna
Abbas,
share my screen.
Yeah. Please, Abbas, please turn off your share screen. Yeah, thank you. My friend, Ali Ahmed, can you share screen? My friend, can you share screen?
I'm sharing my screen, sir. Is it showing?
Yeah. Please explain about your presentation about construction of low-cost housing.
Construction of low-cost house. I took an example for 3D printed home technique exactly.
You just have 25 minutes for your presentation. Please organize the time and timetable to give the better story of your presentation.
Abstract. The printed house is one of the latest and most important global attempts to solve the housing crisis. Based on its speed of delivery and reasonable cost, new versions of such houses are also generally able to meet the requirements of individual families for better than previous standard models, allowing them to be adopted as a model for future housing. The research problem for the current work was thus the existence of a knowledge gap with regard to the applications of printed houses in terms of such adoption. And the research objective was to build a theoretical framework around current and potential applications of printed houses in such a way as to allow this to be adopted as a model for future housing. The hypothesis was the importance of printed house applications depends on the types of future houses supported by market forces. The study found that printed houses offer a solution for temporary housing needs due to their small footprints that correspond to the demographic nature of many modern families. Other positive features such as affordability, flexibility, eco-friendliness, style, and support of healthy lifestyles mean that they also represent the future of housing, by meeting the requirements of individual families more effectively, allowing better customization and a move away from mass production. The table of contents will be introduction and a definition for printed houses, the motives and reasons for change to future housing models, printed house applications, results, conclusions, and references. Introduction. Finding the solution to the housing problems of the 21st century, which include but are not limited to continuous urbanization, overpopulation, pollution, energy and land shortages, and a lack of affordable housing, is not possible by applying the ideas of the 20th century. A shift in models based on the technological development of the fourth industrial revolution must instead provide an alternative to traditional understandings of house design and production processes, fundamentally changing the way people live and work. The use of advanced 3D printing techniques provides new possibilities for designing, manufacturing, and building houses. Yet, there has been so far a knowledge gap with regard to the role of printed houses as a model for future housing. The goal of this research is thus to build a theoretical framework that demonstrates and supports the role of printed houses as a model for future housing. The research hypothesis is thus a premise of the importance of developing printed house applications based on the types of future house supported by market forces. The research methodology followed thus included the following steps. 1. Defining the printed house. Number 2. Studying the transformation in the housing model in light of fourth industrial revolution and the attitude towards and drive of change for future housing models. Number 3. Studying the housing market in light of the determined future housing model, including supply and demand forces and possible types of future house. Number 4. Determining printed house application. Number 5. Achieving a theoretical framework for the printed house as a model for future housing. Number 6. A questionnaire process among a specialized sample to clarify the relationship between types of future houses and market forces based on analysis of examples. And number 7. Developing findings and conclusions. Printed house definition. A printed house is any dwelling with a modern structure in which materials are distributed in layers according to digital layouts to create a three-dimensional model of actual size. Often, a printed house is produced using the contour crafting technique, which applies the principles of 3D printing to housing construction and thus uses automated additives applied to building. Such single layers of concrete, which are repeatedly extruded using a three-dimensional bridge system, building concrete layers on each other in sequence allows the structure completed using technology that applies modern principles of automation to building principles. And it is these houses resulting from 3D printing building technology are the most likely to revolutionize the construction industry. Their most important advantages are reduced costs and build time, reduced environmental pollution, and the possibility of increased energy efficiency from the application of better designs for isolated structures. Motives and reasons for change to future housing model. Motives to change. The motives for changing the traditional housing model to meet future needs were identified by examining the increasing polarization or fragmentation by region and the development of digital technology at the design and implementation levels, as well as the scarcity of resources at both individual and governmental levels. Many of these factors are determined by population growth, population aging, showing economic growth, and persistent levels of poverty. However, perhaps the most important motivation is the maturity of the digital technology sector and the shifting and diversification of values that now supports adopting this technology in housing production. To achieve the evolution of housing development as a product of planning process derived from a population's need, the most important things to consider, which affect the forms and distribution of all future development, are the
You are currently the only
demographic,
person in this
economic, social,
conference.
and cultural factors, including politics, planning, and environmental impact that constitutes the region under development. These control the main result of any future housing model, affecting both production and distribution related to the housing market as well as the resulting housing types. Drivers of change. The most important drivers for changing the housing model from the traditional mode have been identified as follows. First, demographic drivers. These are represented by the needs of two main groups, tenants and small and newly formed families. To obtain small private housing units, the need for availability of small units has thus increased automatically, making this the most important demographic driver for the new housing model. And second, economic drivers. Economic drivers are represented by development costs. Developers currently struggle to meet the need for affordable housing due to increasing costs, which can be much higher than the market price in some regions. A related economic motive is the changing relationship between the future location of the jobs and housing, with some houses and work markets shifting and definitions blurring so that the future picture is mixed. Policy and funding drivers. Development programs and policy shifts at all levels of government increase the complexity of the issue of cost containment, which impedes effective development process, thus negatively affecting national housing programs. Socio-cultural drivers. These are responsible for the distribution and forms of housing development, based on the fact that the situation in the 21st century differs from that of the 20th century. Rented house application. Temporary housing. Disasters leave victims homeless and exposed to external conditions. However, rented houses can be widely applied to construction in disaster-affected areas where needed and at much faster pace than normal construction practices and processes. A portable printer that can be used in humanitarian crises due to its low cost and availability of designs already exists, and 3D printing has proven its ability to build concrete structures such as printed walls easily and quickly, and at lower cost than traditional building methods, as well as reducing construction waste due to using only the materials needed for the structure. It is thus possible to build a complete structure within 3 days, allowing a full neighborhood to be completed within months with a project cost reduced by half. In addition, using local materials for construction is also possible. In contrast, traditional neighborhoods require from 2 to 6 years to build. This technology is economical in terms of reducing costs, materials and labor, achieving a strong affordability in addition to its adoption of environmentally friendly local markets materials, which makes it achieves health aspects with quick achievements and efficiency in producing small units. Benefits are also achieved from it in other aspects. In the short term, temporary house can be produced using 3D printing technology in the design, production, and assembly of small parts in large numbers to speed up production. In the medium term, it can be used to increase the quantity of production and improve various parts of large units to achieve higher quality. While in long term, the application of the computer control aspect to the